Yeah, so hi, I'm Ben. Today I'm going to be doing a quick talk on the Lightning Network. The subtitle is a minimal viable product, which I'll return to a little bit later on in the presentation. And there will be at the end of the presentation as well, just to kind of keep you all here, there will be an exclusive unveiling of a cool thing which I've made, which I haven't shown to the world yet, so that'll happen here as well, so that's quite cool. In the presentation, we're going to be looking at the history of the Lightning Network. So what the Lightning Network is, why it's here, and what effect it will have on Bitcoin and how Bitcoin's used and how people interact with Bitcoin. We'll also look at some of the things which are being built on top of the Lightning Network. The talk's only going to probably be about half an hour long. I'll ask as well that if you've got any questions, if you could kind of remember them, and then we'll ask them at the end. Just so I sort of don't lose my train of thought, which can happen. So without further ado, we shall just jump straight in, I suppose. Okay, so 1st of November 2008, Satoshi airdropped the Bitcoin white paper on the Cypherpunk mailing list, in which he proposed a number of solutions for solving some computer science and engineering problems on how to make a digital cash. So by using things like proof of work, he was able to make scarcity and have a working digital cash. So he dropped it on the Cypherpunk mailing list, and then I suppose anxiously waited for people to respond with questions and queries. It didn't happen immediately. I imagine they went away and they read the white paper and thought it through, and then kind of thought through some decent questions to ask. The first response was from a guy called James A. Donald. And he said, we very, very much need such a system, but the way I understand your proposal, it doesn't seem to scale to the required size. So the first response by the first person, in the first sentence, he's saying, great system, but it's not going to scale to the required size. And then he goes on to say that if you've got a proof of work token, where in order for it to have value, people are going to have a copy of the transactions which have happened, then it's not going to be able to scale to real world use with hundreds of millions of people using it. So this was the first comment which was made on the Bitcoin white paper, okay? It was very telling. So we're gonna start kind of on a very basic level and then work our way up, just to fill in any gaps, if people have got any gaps in their knowledge on how Bitcoin works. So we're just gonna look at transactions, okay? So Bitcoin transactions. So when you make a Bitcoin transaction, that transaction's unconfirmed. It hasn't been confirmed, it's not in the blockchain. Okay, so these are transactions, and they're waiting for a bus, and that's a block. One of these comes along every 10 minutes, and then the transactions get on the bus, they get in the block, and then they get hashed into the Bitcoin blockchain, okay? If there's too many transactions, some of them will have to wait behind, and they'll have to wait for the next block which comes along. And that's more or less, how Bitcoin works in a very simple way. Obviously, there's some issues here. This is the issue with the scaling. So if we have too many transactions and we can't fit them all on the bus and they have to wait for the next bus, then what if that bus is full and then they have to wait for the bus after that? Then you end up with the scaling issue, okay? Satoshi, in his infinite wisdom, in the first release of Bitcoin, he actually had a draft piece of code here. Now Bitcoin, when it first came out, it was actually kind of bloaty. It had loads of functionality in, which no one really needed to use. But Satoshi being Satoshi, I suppose he realized that functionality may be useful at some point. So this little bit of code here, okay, so each one of these transactions which has happened, so say this is Bob has made a transaction to Alice in this transaction here, okay? Well, Satoshi said, well, while it's unconfirmed, while it's waiting for a block to arrive, then we could technically update that transaction. So we could change that transaction. So Bob could change, make an update to the transaction while it's unconfirmed before it gets hashed into the block. So that gives kind of a 10-minute window in which a transaction can be changed, okay? Which, to begin with, this probably just kind of got overlooked as a feature, but then it started to become explored more and more as we're gonna look at. So how does a transaction work? Right, so Bob's made a transaction to Alice. Again, this is a very simple version of how a transaction works, but this visualization which I made kind of helps me understand it, okay? So Bob's going to make a transaction to Alice. Bob has a private key and a public key to his wallet. he sends a message, so he makes a message which says, Bob, give Alice this amount, okay? With his private key, he signs that message, yeah? And then he sends Alice some data. He sends her his public key and the signature data and the message. Alice very quickly can use Bob's public key to verify that this message is valid and it's actually from Bob and it's a valid transaction, okay? So what Satoshi was proposing was that while these transactions here are waiting, that this data here could be updated by Bob. And that may have some use. And this is interesting because you're kind of building time into a transaction. So this concept kind of got explored, and this is a post off Bitcoin Talk by Mike Hearn, one of the old core developers on Bitcoin. And he had a private communication with Satoshi, and he was asking Satoshi, so there was this idea that you could extend that functionality of having an updated transaction by putting a time lock in. So a time lock is it's like the simplest form of a smart contract. So I've got some Bitcoin, and I don't want those Bitcoins to be spendable until next week, or next month, or next year, or in 100 years' time. I can put a time lock on those Bitcoins so they're not spendable, so you can't spend them. So Satoshi explains to Mike Hearn that by using a time lock, that unconfirmed transaction, where you've got an extra amount of time where you can update that transaction, you could put a time lock in, and instead of just having a 10-minute window, you could have a week's window, or a 2-week window, or a 3-week window. And Satoshi said, so nlock time was the original function, which was a time lock function. As Satoshi said, one use of nlock time is high-frequency trades between sets of parties. So if Bob's making lots of trades to, I don't know, Bitfinex or something, then rather than those trades go onto the blockchain, if there's lots of small trades, lots of small high-frequency trades, then it could just be between Bob and Bitfinex. Yeah? It's quite nice as well, because Mike Hearn at the end here, he says, the nlock feature is not used in Bitcoin today, so this feature was taken out for a whole bunch of security reasons. However, it is apparent that Satoshi considered this use case ahead of time, as he did with so many others. So this was really the genius of Satoshi Nakamoto, and the reason we've got Bitcoin is he was able to foresee some of this functionality being useful at some point. Okay? So I'm slowly sort of working my way towards where the Lightning Network came from and why it's here. Yeah? So these are sort of the base concepts. So there's a whole bunch of other posts here on Bitcoin Talk. The next time this was kind of discussed was by a guy called Hashcoin, or girl, I don't know. And in that, he said, well, you could use, you could set up a time-locked payment channel with another person, and it could be done in such a way that they can't screw each other. So if you've got Bob sending funds, what's to stop Bob from broadcasting an old update and not the newest update in that transaction? Yeah? So there's like a big security bug in there. So he kind of started to think about how that could be possible. A guy took that idea called Jeremy Spillman, and he actually knocked together some kind of pseudocode on how that might work. How you could have, me and you could have a payment channel with each other, and I could send you Bitcoin, you know, lots of small transactions of Bitcoin, and that I couldn't screw you. Yeah? That code was then taken by Mike Hearn, Matt Corello, who's currently a core developer. And they implemented it into Bitcoin J. So Bitcoin J was an implementation of Bitcoin, which you could run. And in that implementation, there was the ability to be able to set up one of these payment channels. To set up to open a transaction with somebody, and then not close that transaction, have a time lock in it, so I can do like a high frequency updates on those transactions. Now the only issue with these concepts was it's one direction. I can only send money to you. Yeah, high frequency transactions. Alex Axelrod, he came up in 2014 with the concept of being able to do a bi-directional payment channel. So we set up a payment channel with one another, and then I can send you money, and you can send me money. So it's an open transaction. It's not hashed into the Bitcoin blockchain, and we can send lots of little transactions to each other. So a use case could be, we want to spend the weekend drinking and placing bets. Okay, so we both chuck half a Bitcoin in the pot. I've got half Bitcoin, you've got half a Bitcoin, and then we flip a coin, and then when I win, you give me 0.1 of a Bitcoin, and when you win, I give you 0.1 of a Bitcoin. When we do that all weekend, and then at the end of the weekend then, when the time lock runs out, we say, okay, now this is the transaction which is going to be broadcast to the network. This is the transaction which is going to be hashed into the blockchain, okay? That's going to be settled. So, quite a niche use case, but could be useful for something. Now, Axelrod extended the idea, and he thought, well, if we've got a payment channel set up with one another, and you've got a payment channel set up with somebody else, and they've got a payment channel set up with somebody else, then there could be some way of routing payments through each other. So if I want to send you some money, we could have an open transaction, you could have an open transaction, you could have an open transaction, and I could send you money through those open transactions. So this idea of building up a network of these payment channels started to emerge. Okay? Another sort of theoretical implementation which someone was thinking about was Amico Pay, an excellent project, and that was exploring the same concepts of having these payment channels, these bi-directional payment channels. But there was always a big issue of trust. So how do we trust that we're not going to screw each other, that you're not going to broadcast an old update where you've got more money than me? How do we get past that trust issue? So it's quite a complicated computer science issue, okay? Christian Decker, he was the first person to do a PhD in Bitcoin. And for his PhD topic, he chose scaling. And he looked at something he called Bitcoin duplex micropayment channels, which is setting up these payment channels with one another. All three of these ideas, if given more time and worked on a little bit more, could have very easily become what we now think of as Lightning Network. People really start to see value in an extra protocol layer which sits on top of Bitcoin, where these high-frequency transactions could happen off-chain. Okay? And around the same sort of time, there started to become a debate around scaling on how best to scale Bitcoin. So this was one of the solutions which people thought could be possible. So, 2016, the Bitcoin Lightning Network white paper, was published by Joseph Poon and Theda Strasier. And it's quite a technical white paper because it's a really hard computer science problem to solve. So there's lots of technical detail, so it's a very hard document to read, okay? But in their proposal, they sort of figured out a way of being able to have a payment channel with one another where we don't have to trust each other, yeah? They figured out a sort of technical hack. So, we've got Bob and Alice again. The original transaction which they started with, they put in 0.05 of a Bitcoin each into a pot. And then they do the thing, they make bets with one another. And every time they make a bet, they update who's got how many Bitcoin, yeah? So the first bet, Alice wins, and then the bet after that, Bob wins, and then they place another bet, and then Alice wins again. So Bob's not very happy about this, because now he's only got 0.2 Bitcoin, and in the last round, he had 0.8 Bitcoin, 0.08 Bitcoin. So he decides to publish this old update in the transaction. So he wants this to be the update which makes it onto the Bitcoin blockchain, yeah? So what Joseph Poon and Theda Strasier suggested was that Alice has proof that she's got a newer update to that transaction. So if she presents that proof, she will then get all the funds because it proves that Bob is trying to cheat. So this is a kind of game theory mechanism to stop people from cheating in these payment channels with one another. Okay? So, here we go. The Lightning white paper was really complicated and really hard to kind of get your head around. So a Linux kernel developer, a real heavyweight developer called Rusty Russell, he got involved. And he broke down the paper into a series of blog articles, which made it more accessible for non-geniuses. Still really complicated stuff, but for non-geniuses could read it and kind of understand it, which is great. It also gave a flag to everyone within Bitcoin that if someone like Rusty Russell, who's this world-renowned Linux kernel developer, if he's taken an interest in the Lightning Network, then this thing's got some real validity as a piece of software. Now, in order for this to be possible, there was a bug in Bitcoin. So when we say if I open a transaction with you, that transaction has an ID. If I then start updating, if we start updating that transaction, then that ID can get affected and can change. So if we've got this channel open and it's been open for a week, a month, or a year, then by the end of that month or year, how do we prove that that's the same transaction which we started with? Because the ID for the transaction's changed. So that was, again, another big computer science problem. How do we solve this issue? So the way in which this came through, this is an update which came through last year, we came up with SegWit. So SegWit takes that witness data, okay, and sort of separates it in the transaction from the message. So remember before when we had that transaction, you've got the signature data and then you've got the message inside there. And what this meant was that when we make updates with one another in one of these transactions, the ID for that transaction won't change. So it was a big improvement in the malleability of the transaction. It also meant that the blocks, our bus here, if you imagine that these backpacks are the witness data in a transaction, the signatures, we can now put that data inside this nice storage compartment thing here we've got in our bus, which means we can kind of get more transactions on the bus. This is a very simplified version of how it works, but generally that's how the concept works, okay? The ID for the transaction stays the same, and it improves some scalability. We can get more transactions in each block, which is great. Okay, so just to, because obviously this is all quite technical, just to kind of put what the Lightning Network is into context. I have here some protocols. So this is, we're all familiar with HTTP, but obviously you've got the Ethernet protocol, and then the IP protocol, and then TCP protocol, and on top of that you've got the HTTP protocol. So the IP protocol is a network layer, the TCP protocol is a transport layer where we can transport packets of data, and then HTTP is kind of an application layer. Yeah? So Bob Kahn invented TCP/IP/IP in 1973, and then it wasn't until 1989 when Tim Berners-Lee came up with HTTP that we then had the internet, the modern internet being born. Okay? And obviously from 1989 until the mid-90s when the internet was a thing, it didn't really take very long, but the time from 1973 to 1989 is a bit longer. So this idea that now we've got this application layer on top of a transport layer, it means that you can start building all this functionality. Yeah? So other protocols which sit up here, so you've got HTTP, you've also got like SMTP, which is the email protocol, you've got FTP, which is for transferring files, the file transfer protocol, you've got BitTorrent, if you use BitTorrent and you download films or whatever, not illegally, but if you download films or whatever, then that BitTorrent sits there, okay? And Bitcoin itself sits here on top of TCP. So if you imagine that Bitcoin is kind of like this steady rock of a protocol layer, and then Lightning Network is this application layer which we've built on top. It's a more functional layer. So Bitcoin's great because it's like censorship resistant, it's immutable, it's really sort of solid base. But then we don't want to be building too much functionality into that protocol. It'd be better and more secure to build functionality into a protocol which sits above it. Yeah? So I struggled to find a network map of the Lightning Network because it's so big now. So this is an older map of the Lightning Network, and at this point there's like, 1,000 nodes running on the Lightning Network, okay? So this is that protocol sitting on top of Bitcoin with all these transactions which are opened with people, and then Bitcoin being routed through those transactions. This is all very complicated and confusing, but this might help. Okay, so say call this Ben, right? And say Alice has a payment channel open with Ben. Okay, well Ben has an open channel opened with Susan. Okay, So if Alice wants to send a payment to Bob, then using these open payment channels, using these open transactions which aren't closing, Alice can route the payment through these nodes to Bob. So we may have a payment, this may be Alice here, and then Bob might be over here, and the way the protocol works at the moment is if I want to send some Bitcoin through the Lightning Network, then it can route through and find the quickest route to this node here. And it does it in a way where each node only knows the hop before and after. So by the time the funds actually get to Bob, Bob technically doesn't know that it came from Alice. Yeah, so it's actually more anonymous. There's more anonymity and privacy in Lightning Network than there is on Bitcoin. Because obviously on Bitcoin you can look at a block explorer and all that sort of stuff. So we had this theoretical concept of this Lightning Network, and but we needed to build implementations so people could actually run nodes and actually build the network. So the first implementation was one called C Lightning, and that was by that Christian Decker, the PhD, the guy who did the first PhD in Bitcoin, and Rusty Russell, the Linux kernel developer. They built the first implementation of Lightning network, which is called C Lightning. So basically an implementation is just a piece of software, so you could download C Lightning, and then you can run it. It can, if you've got a copy of the Bitcoin blockchain, it can run it, and you can use it to send and receive Lightning payments, Bitcoin over Lightning. This was the first transaction which happened. Rusty Russell sold Christian Decker a picture he'd made of a couple of cats, I don't know how much for. Shortly after that, I think this was kind of like February this year, so it's already recent stuff, Blockstream, they started to sell some of their products in their store, and you could buy it using Lightning payments. So I could go to the Blockstream's website and I could buy products using Lightning. There was a big disclaimer saying, you may lose funds, this is very experimental, please be careful. And a lot of people in the development community were actually dead against this move because they didn't want people to start putting lots of liquidity, lots of money on the Lightning Network, because it's still, it's experimental. We've just made the thing. We don't know if it's going to work properly. Thankfully, it seems to be working okay. Alex Bosworth, he paid for his phone bill using, he hooked in with Bitrefill, which is a service, and he was able to pay his phone bill using Lightning, which was pretty cool. This guy here, Laszlo, does anyone know who Laszlo is?
Yeah, the pizza guy.
The pizza guy. So he bought 2 pizzas. He's the first person to ever do a transaction on Bitcoin. And he bought 2 pizzas for 10,000 Bitcoin back in the day. 10,000 Bitcoin. So poetically, he also got in there, and he was the first person to buy pizza on the Lightning Network, which is fantastic. It's really good. I'm glad someone else didn't get in there. So it's important to have different implementations, because obviously you don't want just C Lightning to be the only piece of software which people use, because then there's some centralization issues. So currently, there are more implementations you can download and use, but there's 3 kind of major ones which people use. There's Eclair, written in Scala. There's C Lightning, obviously that's written in C. And then there's L&D by Lightning Labs, and that's written in Go. So we've got 3 different programming languages, 3 different implementations. Now, technically they're competing with each other. They are. But there's enough sort of governing dynamics between the 3 that it makes sense to cooperate on so, if L&D decides that they want to try and screw the other implementations by adding more functionality to their implementation, all it will mean that they'll ostracize themselves on the Lightning Network, because other peers on the Lightning Network won't be able to connect to their implementation. So it makes sense that they meet up and they discuss functionality and how functionality is going to kind of be added in, and they give roadmaps onto how they can add functionality into their different implementations. So where are we now? Well, we're starting to get some applications which are being built on Lightning. So it's gone from this crazy hard computer science problem to a white paper and a theoretical, it being theoretically solved, to a couple of geniuses actually building the first implementation, to a couple of companies actually developing other implementations. And now we have a network. We have this Lightning network, and it's sat on the top of Bitcoin, and people are sending and receiving Bitcoin through it. So we've got a couple of, like any technology, when you give the world a new piece of technology, people will experiment with it and explore new business models and whatever, and innovate. So here's a couple of examples of some of the things you can do with Lightning. So there's that bit refill thing we spoke about before. This is quite cool. It's called Satoshi's Portal. This is kind of like a big graffiti wall where you can go and you can draw on it. Another sort of proof of concept idea here, which is pretty cool, is yawls. So if you ever hit like a paywall, so say you're reading an article, and it links to another article, like by the New York Times or I don't know, The Guardian or something, and then you have to pay for a subscription, a monthly subscription, to be able to access that article. So this idea is that because you're able to sell very small payments, you could potentially just pay per article, which you read. That kind of makes sense. So if we click on an article, so where's the channel balance stored? Here. So someone's got an article here, and we can continue reading for half a cent. Is that half a cent? Yeah. Okay. We click here. Hopefully, even though I've got the lines here, it should be able to read the QR code. Let's have a look. Oh, it's a bit annoying, isn't it? I bet if I sort of zoom up a little bit, because there is kind of like, here we are. Let's see if that works. Oh, that's annoying. God, it's really annoying. I tell you what I'm going to do. I'm going to drag that across. Hold on. I'm going to drag that across. I'm going to pay for it on here, and then quickly drag it back. What do you reckon? Right. Okay, so this is for so I'm going to pay it on here so I can actually see the QR code. There we are. That's obviously a technical issue, which, so if I go back to the slide. Sorry guys. Okay. There we are. There we go. So I've got the payment there, yeah? So it's going to cost me 1 cent in order to read the rest of this article. I click on pay, okay? And then boom, look at that. It unlocks the article. Really quick. I didn't have to put any personal details in. It's an anonymous transaction, and I've just paid 1 cent to get some content over the internet, just like that. So this as a protocol layer, this is functional, it's working, and it's building new industries, and people are able to innovate on it. So if you think about currently the way money works on the internet, we haven't got a money native to the internet. We've got Visa Network. Visa Network won't let you pay microtransactions of a cent or a few cents because their network simply can't handle it, and it would cost them too much because they go run servers and blah, blah, blah. Well, so before Bitcoin obviously competed with regular normal currency and Visa Network and all these other payment networks because it's censorship resistant. Nobody owns it, blah, 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 it's immutable, but speed was an issue. Whereas now, with Lightning Network, we're able to send Bitcoin in a way which actually competes with current payment networks. Like Visa can't do this, And if they were to allow this functionality, then they can do, I think, like 24,000 transactions a second. That would fill up. So Visa doesn't scale to be able to facilitate this. Lightning Network scales infinitely. The more nodes you have on the network, I think each channel open can do 500 transactions a second. And we've got 10,000 nodes running right now with all these channels open. So now Bitcoin can actually compete with those current payment networks for speed, which is amazing. It's absolutely fantastic. Another service. So where are we? Yeah. So we've looked at these two. It's pretty cool. There's a WordPress plugin. So if you've got a shop on WordPress, you can use it to accept Lightning payments. There's a Blockstream. They've upped their game. They've now on their store. They've got a whole range of stickers you can buy for Bitcoin Lightning. This is a really cool service. So I use this. This is great. This is by a company called Async, and they're the ones who had that the Lightning implementation of Claire, which you saw before. And this is a great service. So currently, if you want to send and receive Bitcoin over Lightning, then you need to be running, a Lightning node, and you have to have a full Bitcoin blockchain on there, and then you have to download an implementation. It's quite fiddly. It's a bit like almost running your own web server, your own email server or something. It's quite technical. So what they do is they kind of simplify the process, and you can set up an account with their website. And then in it, you can just start accepting Lightning payments. They have an API. You can just accept Lightning payments, these tiny little payments for a few cents here, a few cents there. And then when it builds to a significant amount, like a tenner or 20 quid, it then just outputs to a regular normal Bitcoin wallet. So that's quite a useful way to kind of engage with the system, and something which I've used. So wallets. So we've got a whole bunch of Bitcoin Lightning wallets which are being developed. So the rate of development on the Lightning protocol is so fast when you think that this thing only went live like at the beginning of the year, you know? It's incredible. So we've got a good range of wallets available for Android. iOS is a bit more fiddly because of the Apple App Store, you know, they're a bit more restrictive. If you've got an Android phone, Bitcoin Lightning Wallet's good. I use Eclair wallet. Again, that's by the people who have the Eclair implementation, and they also have the Strike implementation. I just find it really straightforward and simple, and it kind of works. This is Zap. Zap's being developed sort of independently as an open source project. Their wallet's really good, really useful. This is another one, Spark, which is by LND, which is the other implementation. So as we've seen, we've built this new functionality on top of Bitcoin, which allows these super fast transactions to happen through this network of open transactions. So at the beginning of the summer, this guy here, Full Mo, Jeff, he's heavily involved in the Berlin Bitcoin scene. He set up a sort of hack day. So, you know, people come together and figure out how we can use this technology. You know, try and build stuff, build some, you know, web stuff, build some hardware, whatever. He'd had some talks as well. So some pretty influential developers have come and talked at his hack days. He did 3 hack days in Berlin. They were super successful. He also developed this really easy sort of way of running your own Lightning node, or easier way of running your own Lightning node, which I've got here. So you can just, like a Raspberry Pi, and you can just flash an SD card, slam it in there, and then it talks you through the process. I say easy. It's still pretty technical. The last hack day, so he's run 4 hack days in total. The last one, I think he got bored of Berlin, so he decided to do it in New York. And that was pretty cool. We were on Wall Street, and we were opposite the big bull on Wall Street, the big bronze bull thing. I didn't realize, but in front of the bull, there's this little girl sort of standing there, staring off the big bull. And we managed to get this like lightning hat on her and get a picture, which is pretty good. But no, some great projects have kind of come out of these hack days, and it very much feels like the beginning of the Bitcoin community. You've got this new thing, and you're not really quite sure what to do with it. You're just like, well, let's just start building stuff and see what happens, you know. This is quite a good story. So on the first hack day in Berlin, they've got a very iconic bar called Room 77. And that's the first bar in the world to ever accept Bitcoin. It's where the first mobile phone wallet for Bitcoin was developed, because they were fed up of bringing their laptops to the bar to pay for beer. It's where local Bitcoin owners use local Bitcoin. That was also developed there. They've got the longest running Bitcoin meetup in the world. Although yours is pretty good at 5 years, that's quite impressive. So anyway, Yurik, the guy who runs the bar, he's an old school cypherpunk, so he's been in Bitcoin before Bitcoin, you know. And he took a risk at the time, you know, originally when people were, you know, bringing their laptops to the bar to pay for beer, everyone thought, it was really experimental then, no one thought Bitcoin was going to be successful. So he took a risk at his bar, I'm sure it's worked out for him. But after the first hack day, we went to the bar for a few beers, and I was chatting to him, and he was so skeptical about Lightning Network. And he was skeptical about scaling, because he had the issue of people coming to his bar to pay for beer, and then the transaction fees were too high back last year when everyone was buying Bitcoin and whatever, and the network was being spammed. So he was really like skeptical. So for the next hack day, René Picard here and a couple of other developers, they made a really simple point of sale program for which Yurik could put on his phone, which isn't really starting to the wild because it's so experimental, but it works. And that meant that Yurik could start accepting Lightning Network payments for beer. So we all went to the bar then and started buying beer from him using the Lightning Network, and like his eyes lit up. You know, when he saw, like we just saw then, when you make a payment and it's instant. You know, it's and it didn't cost you anything in fees. And then at 7 in the morning, I was like the 6th person to buy beer on the Lightning Network at his bar. 6th person in the world, which I thought was pretty cool. He was in the corner, and he's hacking away on his laptop like this, and he's producing this Reddit post. And it was nice because he's so skeptical, but he says, the scaling debate's over. At the Lightning Hackday this weekend, some reckless people implemented a point-of-sale solution on mobile devices that allows us to accept Bitcoin via the Lightning Network at our bar, room 77. So he went from being like a skeptical, old-school Bitcoiner to somebody who was, he sold. He thought, this is it, this works. This is the application layer for Bitcoin, where people can actually start building stuff and getting excited. In the last hack day, Christian Decker, this is Christian Decker, the guy who did the Bitcoin PhD, and also wrote C Lightning as well. I asked him a question. So at the moment, Lightning's restricted, like the functionality of Lightning is kind of restricted in that if I want to send you a payment, you have to generate an invoice and then make a QR code, and then I scan that QR code and I send you a payment. But then once that QR code's used, then you have to generate a new QR code. And to me, this finally feels clunky. Like it'd be nice to just have a static QR code and I could just send you as many payments as I want on that QR code. So he said, this is something which we're looking at and this is something we're working on. And he said, we wanted, regarding the Lightning Network, we wanted to have a minimal viable product before we started tagging on features. So we look at all this functionality, we look at the speed in which you can make transactions on the Lightning Network, we look at all this innovation which is happening, and that's still on a minimal viable product. Like, the functionality of what Lightning could provide hasn't even been added yet, it's not even been tagged on. So, the idea of being able to stream money, that will happen through Lightning. So you could pay for a service by the second. And when you imagine a world with, Internet of Things, with all these devices communicating and sending value to one another, then we need a native currency which lives on the internet, which can facilitate that. I'm happy as well here that I got a screen grab of his talk. But this was a really interesting slide because, like I was saying before, where you've got Bitcoin as a protocol and then you've got Lightning Network as another protocol which sits on top of it. Actually, the Lightning Network is also layers, built into layers. So that original game theory, if you try and publish an older version of our transaction, I can take all the funds in the channel. That's the LM penalty here. Actually, that process could be done in a whole bunch of different ways, and you can actually build those into the Lightning Network protocol, and you can have a whole bunch of different ways of updating and securing those channels. And the way in which Lightning's been made, that functionality can very easily be added. So I think they've had 10 years of working with clunky old Bitcoin, which is really hard to innovate on, and they've built this protocol so it's much easier to kind of get their hands in and actually start making it more functional. So, while I was there at the Hack Days, I've shown a couple of you this. My little project which I made was the sweep machine. So before there was physical devices people had made where you could pay for something using Lightning Network, but they would have like a full node running inside a sweep machine. And that's like, it's got a whole Bitcoin blockchain on it. You got to like make payment channels with people so you're actually visible on the network, and it's a bit of a pain in the ass. So I thought, actually, something like a sweep machine would be a slave device. This is a master, and you would have, because I can do 500 transactions a second, that would have lots of devices, slave devices connecting to it. So that was the motivation for this. I called it 1.21 after, Back to the Future, because that was pretty cool. I also thought real-world merchants, like I said before, they're unlikely to run their own email server or their own web server, so why would they run one of these things? Actually, they'd probably use something a bit like Strike, where you can send Lightning payments and then it outputs. So a real-world merchant could have a hardware wallet like a Trezor, and then Lightning payments could be sent to Strike, they could concatenate and then spit out to your hardware wallet, and then all which is at risk is maybe 20, 30 quid actually on Strike. So that's the security trade-off. So this is how it works. So I turn it on, it gets an invoice from Strike, converts it to a QR code, which is a pain in the ass, displays the QR code on the e-paper module. Has the invoice been paid? It's just asking Strike, has the invoice been paid? No, it just swoops around, yes, turns GPIO on, and then it spits out the sweets. So, I used a very simple, cheap hardware. So this is actually under 15 quid's worth of hardware here to make it, like a little Arduino board, a little e-paper display thing, and a little NPN resistor, really simple module. You could stick it in a whole range of different things. So now is the time where I'm going to, as I said at the beginning, I'm going to show you the new thing which I've built. the new little bit of hardware, which I think is pretty cool. Again, super simple. I'm an imbecile. So you know, I was pretty impressed that I was able to, oh, here we are, here's the music to build up for the grand unveiling. So I'm obviously sticking with the Back to the Future theme, you know. There we are. So you gonna finish? So I'm gonna play the whole song, is it? Right, so the Flux Capacitor. So this is the Flux Capacitor right here. So I've basically taken that concept of having a sweep machine with an e-paper module, which we can display a QR code, and I've just added like an adhesive, this was £1, this little keypad thing, like an adhesive keypad, and then plugged that into the little Arduino module, and that means that I can input in there, so say if I want to pay 63 Satoshis for something, okay, I hit the hashtag here, that sends the 63 to Strike sends back an invoice, it generates a QR code on there, and then I'm able to get, I scan the QR code, hopefully this will work, I click on pay, and then it's checking, there we are, I get feedback saying the person's paid, and then it just refreshes so you can input another amount. So this is that, so that's like 15 quid's worth of hardware, plus a £2 box and like £1 or £2 little keypad plugged into it. But if you give a merchant this, so someone in a bar, a cafe, or someone in a shop, people can pay using Lightning in their shop, and all they need is this, an account with Strike, that custodial thing, and then somewhere to send the Bitcoin when it concatenates together. You know? So it's a real cheap way to kind of like, for somebody who wants to be able to accept Bitcoin, accept Lightning in their shop, to be able to do it without having to fiddle around too much. I kind of went with the Back to the Future theme because, as we were saying before, with the Lightning came about because there's this time element built into transactions. So originally it was that 10-minute time element where you could update a transaction. And then people use these time locks to extend the time in which you can update those transactions. So to me, Back to the Future kind of made sense because it's all about energy, using energy and time as well. There's this time element in there, and also it's a bit goofy and fun. So there we are. I hope I don't get sued by whoever makes Back to the Future, but that is the Flux Capacitor. This is the grand unveiling, never been seen before in the world. So what's quite cool is that, like, you know, I'm an imbecile when it comes to developing and stuff. This is just me spending a lot of time. It's just me throwing dirt at a wall and eventually it's sticking. I'm able, because this is a fringe technology and not many people are involved in building stuff on it, I'm able to make something which is useful that nowhere else in the world can you pay instantly in a censorship-resistant way using a device like this, apart from in this room. You know, there are other places where they'll have a node running or something where you can pay for something, but this device, this little like purpose-built device, a lot like a card machine or whatever, this doesn't exist anywhere else in the world, and that's cool. Like, we've got that here right now, and like, you know, we're innovating. We're on the fringe of innovation. So that's pretty cool. That's the end of the talk. It was a bit of a whirlwind, so I apologize, but thank you very much.